Good morning, students. Myself Dr. Shantini Bhattacharya, Assistant Professor of EC Department, SRM Institute of Science and Technology, Kattankulathu, Chennai. Today I am going to start a new topic, multiplexer. So today I will cover what is multiplexer, what are the different types of multiplexer, 2:1 multiplexer, 4:1 multiplexer, and also the applications of the multiplexer. So starting with what is multiplexer. Multiplexer is actually a combinational circuit. That means its output depends on at that moment of input, okay, and it is short form is actually MUX. And why it is called MUX? MUX means many into one. In this block diagram you can see there are so many input signals are there, some control signals are there, but there is only a single output signal. So we are already written like that. Multiplexer means many into one. There are many input but give only one output, okay. So here already I have written there are some control inputs are there. So based on the control input, basically MUX select which input signal will go to the output line, okay. So in the next slides I will explain all these things more clearly. I hope all of you can understand. So there are different types of MUX are there. 2:1. 2:1 means, that means here there are basically one select line, and if there is a one select line, that 2 to the power 1, that means two inputs are there but output will be 1. In the next case, that means 4:1, that means two select line. There is two select line. Select line means control line, two control line, but 2 to the power 2, that means input will be the 2 to the power n combination. 2 to the power 2 means 4 will be the input lines but output will be 1. Then 3 select line or control line. So 2 to the power 3, 8 inputs, 1 output. 4 control lines, that means 2 to the power 4, 16 input line and 1 output line. You can see all in this case outputs are 1. Now 2:1 multiplexer, here this is a block diagram. There are two inputs A0 and A1, one select input or control input, this is denoted as S, and one output, this is denoted as Y, okay. So based on this select input, which input, that means A0 and A1, which one will go to the output, it is actually depends on the this control input or the select input, okay. Now I am going to the truth table. It will be then the actually the you can understand more clearly. So now S, this is a single input, that means only one bit. One bit means only one, that means 2 0 and 1 combination, no any other combination. So when S will be selected as 0, then only A0 will go. When 1 will S is 1, then only A1 will go. So just look at the figure again. So when S is 0, then A0 will go to the output Y. When S is 1, then A1 will go to the output Y. So according to the output, the result will be Y0 is equal to S bar A0 and Y1 equals to S into A1, okay. So I have already said that there is only a single output, so final expression will be Y equals to S bar A0 plus S A1, okay. So this is a final expression. So based on this final expression, so this is actually, we have already find out the final expression, A0 S bar plus A1S. This is the final expression, okay. Based on this final expression, we have to draw the circuit diagram by using a basic logic gates, okay. So this is first of all A0 and S is the bar combination. So A0 we have directly give as the input of this AND gate, and S bar, that means this is a select input, then passing through a NOT gate, then it is S bar, then enter into the this AND gate, then it will come A0 S bar, okay. Then A1 S and A1 directly sent to this AND gate, it will come A1S. Okay, then this two output of this AND gate you have to pass through a OR gate. Final expression will come this. Okay, now we first of all, when S is equal to 0, there are two combinations I have already said, S0 and S1. Okay, so when S is equal to 0, okay, at that moment you consider S is equal to 0. So if there is 0, you can see that if there is 0 passing through the NOT gate, it will be 1. It will be 1. Okay, it will be 1, and A0 is also there. So only this AND gate will actually work. Other AND gate will not work. That means here S is 0, and all of you know, if one of the input of the AND gate is 0, output will be 0. So then what will happen when S is equal to 0? Only the A0 S bar combination will, that means A0 data will pass to the output. Okay, when S is equal to 1, then only this AND gate is works. At that moment this AND gate actually, if S is equal to 1, after passing through NOT gate it will be 0. So if one of the input is 0, then output will be 0. So no output comes from this AND gate. So only when S is equal to 1, then A1 will go to the output. Okay, so this is the this is actually the full understanding of the 2:1 MUX. Okay, then I am coming to the next part, 4:1 multiplexer. In the case of 4:1 multiplexer, there basically I have already told 4 means there will be definitely 2 select input. Okay, so A and B, and if it is a 2 select input to the power 2, that means 4 are the inputs and only output is 1. This is Y. So inputs are D0, D1, D2, D3, and based on this select inputs, this which input will go to the output, it is actually based on this combination. Okay, so now I am going to the truth table. That means B here we consider most significant bit, A is least significant bit. So as this is a 2 bit, there is a 4 combination, 0 0 0 1 1 0 1 1. So when 0 0 will be in the control signal, then only D0 will go at the output. When 0 1 is control signal, then D1 is the output. Okay, D1 signal will pass to the output. Okay, so accordingly Y0 will be A bar, B bar, D0. Y1 will be B bar, A, D1. Okay, sorry, this will be B bar. Okay, then this is actually D2 is actually Y2 is actually this is B A bar D2. It is little bit there is a wrong. It is wrongly written. It will be B bar. It will be B A bar D2, and finally this one is B A D3. So this is actually the final output will be a single output. So all these outputs we have to add. Okay, so now based on this we have to draw the circuit diagram. Okay, so at that moment we only consider two combinations, 0 0 and 1 1. Okay, so AB is 0 0 and AB is 1 1 we only consider. So when 0 0 is there, we know when 0 0 combination is there, only D0 will pass. Okay, so just according to the we have already drawn the circuit. So when 0 0 combination, we have to check whether really the D0 only pass or any others also pass. So just look at that 0 0, that means in the this AND gate, okay, only at that time works. That means this is actually when A is 0, A bar is actually 1. So this is 1, this is also 1, that means this is actually B bar, and D0 also there. So only this AND gate, all the inputs are actually high, so it will actually works. Okay, In other AND gate, if you look into this, that if I consider this one, okay, here you can see D3 is one input, okay, but there is connected to B. At that moment B and A both are 0 0. So as we directly pass this to the AND gate, then it will be 0. If, and all of you know that if one of the input of the AND gate is 0, that means output will be 0. So when we will give only 0 0 combination, then except this AND gate, all other AND gate output will be 0. So at that condition, only this output result will go to the final output, that means Y. Okay. Then again I have taken another combination 1 1. Okay, 1 1. So 1 1 means only, if I check last one, 1 1 means D3 will go. Okay, so that means if I consider 1 1, okay, 1 1 means you can see that D3 directly connected to this AND gate. Then there is another one, this A is directly connected here and B also directly connected here. So when 1 1 combination is there, only this AND gate is high, other all AND gates will be 0. Just I am look into this AND gate. Okay, look into this AND gate, 1 1 combination, but it is connected to A bar and B bar. So if I have given A and B 1 1, then A bar and B bar will be 0 0. So this AND gate other two inputs are 0, so it is 0. So here also this is connected to A bar, so it will also be 0. Here also, here in this case all the combinations actually go except 0 except this D3. Okay. So this is the 4:1 MUX principle. So now the application is like that. This is the MUX, and I have this already said that this is the control input AB. So 0 0 0 1 1 0 1 1, and there are 4 inputs are there. So in the D0, MP3 player is connected, D1 laptop is connected, D2 digital satellite is connected, D3 digital cable TV is connected. Okay, so an output only a sound system is connected. So according to the combination, that means when 0 0 is select, then only MP3 player input is go to the will go to the sound system. Okay, with 0 1 combination is select, then laptop input will go to the sound system. In this way also 1 0 and 1 1. And these are the main applications of the multiplexer, like communication system, telephone network, computer memory, transmission from the computer system of the satellite system. So thank you so much. Keep watching students all my videos. If you have any doubt, then give me this doubt in the comment section. I will try to solve all the comment. Thank you. Keep watching.